All right, so last class we looked at different types of chemical reactions and chemical equations that represent those reactions. And today we're going to talk about balanced reactions, which means we're going to look at how we satisfy the law of conservation of mass. So let's review here. The law of conservation of mass says that no atoms can be created or destroyed during chemical reactions. So when a chemical reaction takes place, atoms don't disappear and they don't come from nowhere, right? So it basically is saying that whatever you put in, you have to get out, right? So whatever goes in to a chemical reaction, these are called the reactants, right? Let's remember that from last time. And whatever we get out is called the products. But we know after looking at lots of these chemical reactions that what you put in, you don't get out in the same chemical formulas. But what happens is the reactants break bonds, those atoms rearrange and form new compounds that are the products, right? Because in order for a chemical reaction to take place, something new has to form. So those atoms that you put in have to rearrange, form something new, and then then are considered your product. And so it's true that the number of atoms you put in have to be the same as what you get out, but they're going to be in a different arrangement. All right, so when we balance our chemical reactions, we're going to look at one atom at a time. So what that means is that if we've got carbon on one side and carbon on the other side, we're going to look at those carbons and see, do we have the same number of each of those carbons on both sides? And do we have the same number of hydrogens on both sides? And I do want you to kind of be able to recognize that balancing equations might take more than one try to get it right. Okay, it may take you a little bit of back and forth to finish balancing the reaction, but there's only one right answer. There's only one right answer. So it might take you a few tries to get to that right answer, but there is only one. So you always are going to be able to check your answer to confirm that you're right. So let's look at this chemical reaction here. It's listed down below. H2 plus Cl2 yields HCl. So we have a molecule of hydrogen gas, H2. We have a molecule of chlorine gas, Cl2. And it says it's going to form a new compound, HCl. Okay, so you have H2 combining with Cl2, which is going to form a new compound, HCl. And so what we're looking at here is, I kind of gave you a little picture here to see it first, but this equation is not balanced because we put in 2 hydrogens to our chemical reaction, and yet when our product is listed here, I only have 1 hydrogen there. Right? This 2 means that there are 2 hydrogen atoms, and here there's no subscript by that H, which means there's just 1 of them. Okay, and I want you to look at chlorine as well. We put in how many chlorine atoms? We put in 2, right? And if you look up at the picture here, we see we've got 2 chlorine atoms that are being put into my chemical reaction. But in my product, I only have 1 chlorine atom listed. So now the question is, how do we fix that? All right. We're going to look back at those coefficients we talked about a couple classes ago, because when we add a coefficient, that tells us we need 2 of those molecules. And so I want to look at, we have 2 hydrogens, but here we only have 1 hydrogen in that molecule. So I need 2 of those molecules to make it work, right? I need 2 of those whole molecules. And by putting a 2 in front, of this HCl, that means I have 2 hydrogens and 2 chlorines, which then satisfies my Cl2 problem as well. So if you look here at the picture, by having 2 HCl molecules, I'm now balanced, right? 1 molecule of HCl, 2 molecules of HCl, and that's what that 2 there represents, that we have 2 of those molecules. So by having that, 2 H's, 2 H's, 2 Cl's, 2 Cl's, that is considered a balanced chemical equation. And that's our goal every single time, is to have our equation be balanced. So that means we have 2 hydrogens on the left side and 2 hydrogens on the right side, 2 chlorines on the left side and 2 chlorines on the left side. These are balanced, right? They each are the same. Okay, our hydrogens match and our chlorines match. So I wanted to talk about a couple things here as we start practicing with balancing equations. We never add coefficients in the middle of a chemical formula. They only go in front of the entire compound. So if I'm going to look at the compound HCl, just like we had it, let's say my reaction told me I needed 2 chlorines. I cannot just do that, right? I can't add a 2 in front. I cannot add a 2 right there. The only thing I can do to balance my formula is add a coefficient in the front, because that tells me I have 2 of the whole entire molecule. So I cannot take a molecule and change any part of it. I can't add a 2 there. I can't put a coefficient there. I can't add a 2 or a 3 or whatever, any number. I can't modify the chemical formula itself. The only thing I can do is put a number in front. Okay? Second thing I want to remember is that we never change subscripts in a correct chemical formula. So same type of thing I was just talking about. If we have a formula that looks like this, H2S, and let's say I needed 3 hydrogens or 4 hydrogens, I can't just change that to a 3 or to a 4, right? If I need 4 hydrogens and I have that compound, I would put a 2 in the front of it, because 2 hydrogens times 2 molecules would give me 4 hydrogens total right there. Okay, and it would give me 2 sulfurs. All right, let's think about that again. If I have a 2 right here and I put a coefficient in front, those multiply together to give me 4 total hydrogens. And I have a 1 right there, right? We assume there's a 1 right there. That means I have 2 total sulfurs. Okay. Last thing I want to look at here is if we have a balanced chemical reaction in which our coefficients can be reduced, we need to reduce that down. And I'm going to show you that as it comes up. But the only way that that would happen is, let's say we have this formula here for, just a basic chemical reaction. A plus B yields A, B. And let's say we had in front of it coefficients of 2, 4, and 2, right? Well, all of these coefficients are reducible by a 2. So I would reduce those down and say 1, 2, 1, and my final formula would be A plus 2B yields A, B, right? That doesn't happen that often, but in case it does, those coefficients, as long as they reduce by the same number, can be reduced. So let's try this one here. I'm going to show you the way that I balance chemical reactions, and I like to make a list when I do that. Okay, so I'm going to make a list of every single element that I have that I'm working with. Okay, so I've got copper, I've got silver, I've got nitrogen, and I've got oxygen. I make a list of all of the elements that I have present, right? Cu is an element, Ag is an element, N and O, all elements. Okay, and the next thing I do is I kind of give myself some space to work, because on this side of the list, I'm going to count all of the atoms on this side of the reaction, right? I'm going to put all my reactants over here. On the other side, I'm going to list all of the atoms in my product, right? They're the same atoms, but I'm going to count them. So on the left side of my reaction, over here, I have 1 copper atom, right? I have 1. If I look at silver, Ag, I have 1 of those. I have 1 nitrogen. And how many oxygens do I have? Right? This 3 here only refers to the oxygen. It does not refer to any of the rest of it. Okay, the 3 here only applies to oxygen. So I have 3 oxygen atoms. So now I've got all my reactants counted. In order to have a balanced reaction, I have to have the same number of each atom on the left and on the right side of my reaction. That's the whole point, is that I want to get them to balance. Okay, I want to satisfy the law of conservation of mass, which means I've got to have the same number of copper atoms on both sides of my equation. I have to have the same number of silver atoms on both sides. And so I'm going to have to manipulate this equation a little bit to get it to balance. So let's count on the right side. I have 1 copper. Okay, nitrogens, I have 1 here, but this parentheses tells me that I have 2 of those molecules. So I take 2 times a 1, and I know I have 2 nitrogen atoms. Okay, let me go through that again. When there is a number outside of the parentheses, you multiply that to whatever subscript is there. And it's a 1, right? We think it's a 1 right there. So 2 times 1 is 2. For oxygen, there are 3 oxygen atoms per molecule and 2 of it. So 3 times 2 is 6. Okay, so let me just draw up here so we have a little bit of an idea. This copper molecule looks like this. CuNO3, NO3, right? I have 2 NO3 compounds attached to this copper. So when I go to count those atoms, 3 oxygen plus 3 oxygen, or 3 times 2, gives me 6. Okay, that's how I came up with that number. We're going to practice that a lot, but that number outside the parentheses gets multiplied through there. All right, and then lastly over here, I've got 1 silver. So that's the first step in balancing a reaction, is that I have to count all my atoms. Okay, so that's done. Now I'm going to look at my list and see, well, where is it balanced? So far it's balanced at copper and balanced at silver, but my nitrogen and my oxygen are not balanced. These numbers do not match, right? I only have 1 nitrogen atom on this side and I have 2 on this side. So I have to find a way to fix that. Okay, and the only way to fix it, remember, I cannot put a 2 right there. I cannot put a 2 right there, right? The only thing I can do is put a 2 in front, right here as a coefficient. Okay, so now I have to recount on the left-hand side. By adding a 2 there, did it affect my copper atoms at all? No, right? But it did affect silver. Now I have 2 silver atoms. I have 2 nitrogen atoms now, and I have 3 times 2, which is 6 oxygen atoms. Okay, so now I rescan my list and I say, oh, okay, well now my nitrogen is balanced, my oxygen is balanced, my copper is balanced, but my silver is not. I have 2 silver atoms on the left, but only 1 on the right. So I come here and I add a 2, right? I cannot add a subscript. I only add a coefficient, right? So I add a 2 there, and that changes my list, right? I don't have 1 silver atom anymore on this side. I have 2. So now I can go kind of rescan my list again. I've got 1 copper on both sides, 2 silver on both sides, 2 nitrogen on both sides, 6 oxygen on both sides. So this is a balanced chemical reaction. Okay, so we assume here that this is a 1 and this is a 1, but you don't have to write in the 1s. You can just leave them off. Let us try a couple here, and then I'll let you do one on your own. Okay, so I'm going to make my list over here for the first one. I've only got 2 elements, Al and Br. So I make my list, and then I give myself room on the left and on the right. Remember, the left-hand side of my list is about my reactants, and the right side of my list is about my products. Okay. So on the left-hand side, I only see 1 aluminum atom. I see 2 bromine atoms. On the right-hand side, I see 2 aluminums and 6 bromine. So right off the bat, I can see, well, it's not balanced because aluminum is not balanced, and aluminum's not balanced, and bromine is not balanced either. So I'm going to look at my list here and see which of these is the easiest change for me to make, right? Which of these is the easiest thing for me to fix? And to go from 1 aluminum to 2 is pretty easy, right? Because I'm just going to change this coefficient. Instead of a 1 being there, right? We assume it's a 1 if there's nothing there. I'm going to just change it to a 2, right? I'm going to add a 2 in front because now that means I don't just have 1 aluminum atom, I have 2. And so my aluminum is now balanced, but my bromine is not. I currently have 2 bromines, but I need to have 6. So what coefficient needs to go here to make the left side of my equation have 6 bromines? Right? It has to be a 3. Okay, so this is the reaction that has to take place in order to form a single molecule of that product, right? You do not need to put a 1 there. We know there's already a 1 there, but you don't have to write it in. Okay, so in order to get a molecule of Al2Br6, you have to put in 2 atoms of aluminum and 3 of these bromine molecules, right? This is what a chemical reaction is saying, that in order to get this product, in order to get this amount of this product, I have to put in this combination of reactants. And so that's the whole point of a chemical reaction here. All right, let's look at the second one now. I have 2 elements in this one as well, K and Br. K is potassium, Br is bromine again. On the left side, I have 1 potassium and 2 bromine, and I have 1 potassium and only 1 bromine on the right. So I've got to change something, right? My bromine is where there's a problem. Br is where there's a problem. So I'm going to take this here and add a 2. But that doesn't only change bromine, it changes potassium as well. So now my potassium is no longer balanced. I have to come back to the left-hand side and adjust potassium. And so now I can look at my list and say my potassiums are balanced and my bromines are balanced. So here we assume there's a 1. Again, you can write it or you can leave it off, whatever is more comfortable for you. This next one here, I want you to try on your own. This last one here, I want you to try on your own. There is another one listed on your printed notes, but that can be skipped. That one's a little more intense. So I'm going to pause it here, and you pause the video as well and work out the problem, and then I'll have the answer up here in just a minute. All right, so on this one, if you notice, the first thing I did was change this from a 1 to a 2 because my hydrogens on this side would never be a odd number, but I had an odd hydrogen out here, so I had to get it to be an even number of hydrogens on the right-hand side. So that was my first move, and then I kind of trickled down from there. Okay, you'll notice that when you adjust something here, it usually causes a change on the reactant side. And then it will cause a change on the product side and whatever. You might go back and forth product to reactant a couple different times with your list, but the balanced chemical reaction for this should be 1, 2, 2, 1, right? Or 1, 2, 2, 1. 1 nitrogen. Oh, whoa. No, I messed that up. Sorry. 2, 2, 2, 1. Let's double check this again so I don't mess something up here, but 2 sodiums, 2 sodiums. 2 times 2, which is 4 hydrogens. 1 times 2, which is 2, plus 2 more is 4. 2 oxygens, 2 oxygens. Okay, so yes, I think we're good. 2, 2, 2, 1. All right, why don't you take some time and practice as many of these as you want. I'll go ahead and put the answers up here in it in just a minute. So go ahead and pause. Practice these as much as you'd like, and then I'll have the answers up in just a minute. All right, here are the balanced reactions here. You'll see that this one was actually already balanced. The other ones, I put in all the coefficients. Again, if you did not put in the 1 to balance the reaction, you just left it blank, that's fine. We assume there is a 1 there, so it's not that big of a deal if you don't put that on. But if you're unsure at the end, just make sure you go count, right? If I look at this first one, I've got 1 lithium times 2, which is 2. 2 lithiums over here. I've got 1 chlorine times 2, which is 2. 1 times 2, which is 2 over there. 2 sodium, 2 sodium, 1 sulfur, 1 sulfur, right? I made my list when I was doing them, but I didn't put them here on this final screen. I will encourage you to make that list while you're balancing them, just to get some more practice, but that's the simple concept, is that there's got to be the same number of lithiums on the left as there is on the right. Same number of chlorines, same number of sodium and sulfur, right? Whatever you put in has to come out, just in a different arrangement.